Kende, you can continue. You're muted, Kende.
Oh, sorry. So we are starting with C# constructors now. So a constructor is a special method that is used to initialize objects. So it is a special method that is used to initialize objects. So the advantage of a constructor is that it is called when an object of a class is created. That is, immediately you are creating that object of that class, the constructor method is called first before the instance of that class is fully created. So it can be used to set initial values for fields. Note that the constructor name must match. So these are the things we need to understand. One, the constructor name must match the class name. And it cannot have a return type like void or int. So, in that previous class, I explained that for methods, you need to identify the return type of that method. That is when you are creating a function or a method in a class. But for this special type of method, which is called constructor, it doesn't have a return type. Also, note that the constructor is called when the object is created. All classes have constructors by default. So by default, all classes in C# they have constructor. So even if you do not explicitly define a constructor in your class, by default, the class has a constructor, just that the constructor that the class we have in that instance will be a parameterless constructor. So if you do not create a class constructor yourself, C# creates one for you. However, then you are not able to set initial values for the field. So let's look at this to explain what we are saying here. Okay, I'm going to be commenting this. So now this is another instance of that same card class, right? But if you look at this now, you notice that we have a difference between this and the former instance, and the former class, car class that we have. Now, in this one, you notice that there is a method here, but the method does not have a return type. That's one. And two, the method has the same name as the class. Okay, so this is called a constructor. This is the constructor of this class. And whenever we are now creating an instance of this class, this method, this constructor method is called first before the instance of that class is created. So we are going to be running through this in a debug mode. Then you now see what I just did. I just put a method here to display the model. All right. But you now discover that I did not assign value to this model class here. The value was assigned inside the constructor, right? And you will see what this class will display. What I emphasize here is that whenever you have a class in C#, the constructor of that class is called before the instance of that class is created. So let's just run through this in the debug mode. Okay, so let me set a break. I'm setting a breakpoint here. Then running this. So they're stepping through. You can see before that instance is created, the first method that is being called here is the constructor of this class. So you can use constructor to quickly set some basic things that you don't need, that you needed. You might decide to expose them. You might decide not to expose them. But since those properties or feats are needed for your class, you can use the constructor. It's faster. You can use it to just quickly assign values to them. So the constructor class is called first. Let me put a breakpoint here also where we call that function. So you can see we assign value to the constructor, to the field model there. Then we come back, the bug comes back here and finish up creating the instance of the class. So before finishing, fully creating the instance of this class, we notice that the constructor method has been called. Then we can now access this method, display model, right? And the method is now being called. And in our console, you can see what we have now is Mustang. But this Mustang was not assigned to here. It was assigned to in the constructor method. So the point to take home here is that whenever you are creating an instance of a class, the constructor method of that class is called first. And in C#, you do not always need to explicitly define the constructor of your class. If you don't, C# under the hood, the runtime, the common language runtime will create a constructor for you, and so that the instance of your class will be easily created. So it's not always compulsory to explicitly create a constructor of the class. So I hope we all get that clear. All right, so let's move on to the class. All right, so okay, before we move further on that, I think I have another method to just explicitly explain what we have. Okay, so I'm going to be using a class called circle. All right, let me just comment this. So this is a class called circle, right? So I believe when from our secondary school or primary school days mathematics, we know that the formula for calculating the area of a circle is I think it's pi r squared, right? So sorry. Okay, so it is pi r squared, that is pi multiplied by radius again, right? I think that method is correct for calculating area. So let's just quickly look at this class, circle class. Please correct me if I'm talking too fast so that we can all be on the same page. All right, so for this class, we have a field called radius, right? Because every circle is made up of radius, right? Then we also have a constant value for pi in mathematics, all right, which is 3.14159. That is the value for pi. So now we have the constructor for this circle class, all right. Another thing to note about constructor is that if you are explicitly defining a constructor for your class, you must declare it as public, all right. You can put some identifiers there. So you can define it as public, you can define it, but if it is a constructor that you want it to be accessed by other classes, you need to declare it as a public. So this, for us to model a circle, right? That circle must have a radius. So you must pass in whenever you are creating an instance of a class called circle, in this case, you need to pass in the radius of that circle, right? Then we now have a method, all right? And what does the method do? It just calculates the radius of the area of the circle, and it returns back the area of that circle. So basically in this class, we have two fields, which are radius and pi. We have a constructor of the class, which accepts a double type as it accepts a double type as the parameter, right? Which we refer to as the radius of that circle. Then what do we do inside the constructor? What we did is that we assign this constant value of pi to the circle, and also we assign the passed in parameter, right, as the radius of that circle. Then we have a method that calculates the radius of the circle. So let's put this in use in our code, right? So we have so what we are just doing here is that we have we created an instance of that circle class. You can create as many as possible instances of the circle class. You can create another one. Let's say circle second circle. Let me just call it second circle equals to new circle. Okay. Now, you notice something, that this is throwing an error here, right? So can anyone tell me why this is throwing an error? Anyone? You can just unmute and speak up. I just want to be sure we are together.
Okay, good evening.
Good evening.
I think it's throwing an error because no value has been passed into the circle constructor.
Good, good. Thank you very much. So, we already explicitly added constructor to our circle, and the constructor entails that you must pass in a parameter to it whenever you are creating that instance. So this is throwing error here now because we've not passed the parameter to it. So we can just pass any value, let's say 5.8 as the value. Then let me just do the same thing here. So we are just passing that, and we are now calculating the area. So you can see the way we call the method of that class. All right. We just you use a dot sign to access it, and also you use you put parentheses to call it as a routine or as a function of that class. So let's quickly run this on debug. I will need to just be fast with this so that we won't just take much of that time. So here now we've created the instance of that class, and we've also created the instance of the second class. So now on our console, we should see. So for the first one, that is the radius, and for the other one too, that is the radius of that particular class. So that is just that's that about constructor. All right, okay, so that's that about that. Now let's go to the next thing we have on our agenda for today, which is the access modifier. Okay, we are almost done with the class. After the access modifier, we just wrap up with encapsulation. that will be the class for today. So let's quickly run through this. Access modifier, just as the name entails, access modifier. That is, it's only this one. What it does is that it determines the access level to any property or function, or even the class itself, whenever you are creating an instance of the class. All right. So access modifiers are keywords that define the accessibility of a member, class, or data type in programming or in program, right? It determines the access level. These are mainly used to restrict unwanted data manipulation by external programs or classes. So yesterday I was trying to tell us that basically what we do in programming is we are manipulating data. We are manipulating or modifying data, right? We are just playing around with data. So that's why in computer programming, there must be an input, all right? You must pass in variable for your program to work on that variable. So your program can manipulate the variable, it can do anything with the variable. Take, for example, like my circle class that we have. We pass in the variable for example, to a class, and our program works with it and give us back the area of that circle. All right, that's just basically what programming is all about. We are manipulating data. All right, so when we are manipulating data, there are some data that must not be modified, right? Because if anything happened to those data, it can crash your system. It can crash your program. So as a result, you need to create restriction level for such type of property or class or data type. So that's why we make use, that's where access modifier comes to play. It helps us in doing that. So we have public. We have 4 of them. One is public, the other one is private, we have protected, and we also have internal. Okay, to explain this, let me just comment out so that we can get it along. So we have public. So the code is accessible for all classes. When you declare a field or property or a function or a class itself public, anywhere you have the instance of that class, you can access it. If you declare a field or property of a class public, anywhere you create the instance of that class, you can access it. Okay, so it is accessible anywhere. So that's why, for example, in this method is declared public, and that's why we can access it here. Okay, then we have private. The code is only accessible within the same class. That is, you can only use that code in that class. Once you declare it as private, it is private to that class. And in modeling up your class, when you are defining your class, for example, I call this double radius, I call this double pi. By default, they are private. Okay, they are private by default. Okay, they are private because I did not explicitly, I not explicitly put it as private, but the system by default in C#, once you don't put identifier in your field, it is implicitly defined as private. But if I want it to be public now, I will just put the public identifier there and it should be made public. Now, so for private now, for example, let me change this method to private. Let me change this method to private. So declaring this method as private now, you can see we have restricted red line here. It's showing us that something is wrong. And one good thing about C# is that you can see what is causing it. You can see that we have it here that calculate area is inaccessible due to its protection level, right? So because it is private, I can't access this method. And if I just, let me put a dot now to access it, you can see I can't see it here because it is private, all right? Then let's move on. Let's go to protected. The code is only accessible within the same class, right? The code is accessible within the same class or in a class that is inherited from that class. So in our next session, we'll talk about inheritance, all right? But when you declare a method or a class as protected, so the object of that class can only be accessed by the class that inherits from it or within its class alone. Okay, so even if we still declare this as protected, you can see it's still showing this treated red line. That is, it can still be accessed. Okay, so let's declare, then we also have the last one, internal. The code is only accessible within its own assembly, but not from another assembly. All right, so that is within the namespace, you can have access to that class. So I'll be declaring this as internal. I'll be declaring this as internal. So you can see we don't have the restricted line again. So I can put dot calculate area. So it is now accessible because they are still within the same assembly. So that's why I can access it. Okay. So I think that's just that on access modifier. Any question before we move ahead to the last topic for today? Any question?
You guys should respond now. Any questions?
I will take our silence that we all understood what we've done. Or you might still need time to go over the class again or read other materials about these topics so that you can have questions.
Mr. Kinde, thank you very much. At least, sincerely speaking, you have explained all these concepts in a simple manner. I would just appreciate if you can go through the section of method about private, public, and other types. You know, because from the code you make use of public much than others, so that you can see others in the code.
Okay. All right. So
before you continue, I think Damola wanted to say something. Damola, are you there? We cannot hear you. You're unmuted, but we cannot hear you.
Can you hear me now?
Yeah,
yes.
I think, yeah, we can hear you now.
Yeah, so no, when he was just talking about, I was just about to talk for follow-up, since he said, is anybody understanding what he actually said? So it's not like I have a question.
Oh, okay. All right. So you can go ahead, Kenny.
All right, thank you very much. So for the public, private, protected, and internal, all right, I will just quickly rush over it again. Then I will, for now, just focus your mind on public and private, all right? Protected and internal, you can read more about that, and also, by the time you start using it in your code, you understand it the more. So for public, right, you can define your class, we said it is the access modifier can be used on classes. You can use it on class. You can use it on the properties or feats of that class. And you can also use it on the method of the class. Okay, so I can declare this class as public. Once I declare it as public, it can be accessed anywhere in my code. Okay, or I can declare it as private. If it is private, that means it cannot be accessed anywhere. Okay, it can be accessed anywhere. But I can also declare it as protected. Declaring it as protected means it can only be accessed by a class that is inheriting from this circle class. So about inheritance, you can just spend that for now. By next week, we will dig deep into what inheritance is. Then I can also declare it as internal. So once it is internal, it can be accessed within the assembly, which is also, we can also refer to it as a namespace. Okay, or I can also put it as a folder. Yeah, let me put it that way. So it can only be accessed by the files that are in the same folder. That's what I mean by assembly. All right, for example, you can have a folder, you can have many files in that folder. So when you declare a class as internal, all the files, all other classes, all program.cs files in that folder will be able to access the class. Why? Because they are still within the same namespace. They are still within that namespace. So if you declare a class as internal, or you declare a method as internal, or you declare a field as internal, the access level is just within the namespace, or within the namespace, or within the assembly of that class. So I hope that explains, gives us more light about what I've explained earlier on that. All right, so let's just move to the last topic before us for today, which is principles of OOP. Okay, so please, even if you don't take anything from this class, aside from what we said earlier, this is core to Johnny as a C# or .NET developer. All right, so what are the principles of object-oriented programming? We have 4 basic principles, which are 1, encapsulation, right? 2, inheritance. 3, polymorphism. And 4, abstraction. So my session in our sessions to come will be digging deep into inheritance, polymorphism, and abstraction. So for this class this evening, we'll be just be dotting our eye with on encapsulation. Okay, so what is encapsulation? I believe we've some of us while growing up, we've taken some drugs. They call them capsule, right? You notice one thing about those, there's this type of drug that we used to take. I've forgotten the name now. Okay, this tricycline or so. You see it's just a capsule. You don't know what is inside, isn't it? But you know that if you are punching, once you take it, it's going to work. All right. So the content inside has been hidden from you because you don't even need to know what it is. It's just for you to take, and it's for it to work. Your body to dissolve it, and it will just work in your body. So that's just the same thing. We can also put that into encapsulation, right, in programming. So that is a class or object or method that the user does not really need to know how it's being implemented. All right, it doesn't really need to know how it's being implemented, but it just knows that once it call it, the class will do the right thing. Take for example here. can see here, what we just do here is that we are creating the instance of circle, and we are creating and we are calling the class calculate area. How this circle class calculate the area is none of the user's business. User just know that this program, once I pass in a value, it must return to me the area of the circle. All right. This is just a simple example of encapsulation. All right. The method is in use here, but it is abstracted or hidden from the caller how the method works. All right. So let me just read through what we have here. Encapsulation is sometimes referred to as the first pillar or principles of object-oriented programming. A class or struct can specify how accessible each of its members is to code outside of the class or struct. Methods and variables that aren't intended to be used from outside of the class or assembly can be hidden to limit the potential for coding errors or malicious exploits. Okay, that is, you have some fields in your class, but those fields in your class can be maliciously used. That is, it can be corrupted. So because of the way it can be corrupted, you can create a form of access level to it so that it won't just be accessed. It won't just be accessed anyhow. All right. So in object-oriented programming, encapsulation refers to the bundling of data with methods that operate on that data, or the restricting of direct access to some of an object components. Okay, you are restricting access to those properties. Encapsulation is used to hide the value or state of a structured data object inside a class, preventing direct access to them by clients in a way that could expose the implementation details or violation or violate state invariants maintained by the methods. Okay, so that's just the simple meaning of what encapsulation is. All right, so we are restricting access to some properties or some fields that you know that if it is being maliciously used, it can break our code or it can break our program. All right. So publicly accessible methods are generally provided in the class to access or modify the state more abstractly. The meaning of encapsulation is to make sure that sensitive data is hidden from users. To achieve this, you must declare fields / variables as private. So we'll be looking at this in a short while now. So this takes us to properties. I noticed, okay, I'm sure some of us will have seen properties while declaring a class in some of the codes that you might have seen online. You have seen people using get set, using the getter and the setter, and doing some things around the get and the set. Okay, so that is what we refer to as property.
Just so you know, 5 more minutes on this call.
Okay, all right. Maybe we can just stop the class so that we can just start with properties on the next one.
Okay, so do you want me to start another one?
Yes. Let's start another one so that we can rush through this.
Okay, so everyone, I'm going to start another one. We're just going to use it to round up, and then we can do Q&A after that. So
yeah, max is 7 minutes. We should be done.
Okay then. All right. So just join back for us to have a round up.